Eric Burgess here, and we've been given the following sequence. They want to know, does it diverge, converge? If it converges, what value does it converge to? So we're looking at this, we say, okay, we've got our sequence. We notice right away it's an oscillating sequence. And so looking at oscillating sequences, you may recall, we know that if the absolute value of a sequence, if the limit as n goes to 0 of the absolute value of the sequence, whoops, not to 0, to infinity, as n goes to infinity of the sequence, if that limit is 0, then the limit as n goes to infinity of the sequence is also 0. So if we could show this, then we're good. And what's nice about this is there's an absolute value, which gets rid of the oscillating sequence for us. And so we're going to go ahead and do that. So let's go ahead. Let's take a look at this thing. We say, okay, well, first we apply absolute value. If we do this, absolute value at the top, negative goes away. So now this is basically just 1 to the n. And on the bottom, 2 to the n, absolute value has no impact on this at all anyways. So it becomes 2 rad n. So 1 to the n, any n, is just going to be 1. So we can lose the n. We don't need it. I'll go ahead and do it visually by just scribbling it out here. And we're left with this. Now this is a very easy sequence to take the limit of. Limit as n goes to infinity of this thing is 1 over infinity, which will give us 0. And so here we get 0 and we say, okay, well, that's the absolute value version. So this therefore means that the sequence goes to 0 by this theorem. So 0 is where this sequence will converge to. So if you see an oscillating term like -1 to the n, this is going to be one of the things you can do to try and get an answer out of it. If you have any questions about this, feel free to let me know. Subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.